Today we will solve the problem 2.11 of Griffith third edition Introduction to Quantum Mechanics. It consists of three parts. Part A is compute the expectation value of x, p, and the expectation value of x squared, p squared for the state psi 0 and psi 1. By explicit integration. So equation 2.60 is this one, 2.60, and this is 2.63. And for simplicity, it is given for a simple harmonic oscillator problem. We will take for simple harmonic oscillator z is equal to square root of m omega h cross x, and alpha, that is normalization constant, this is equal to a. Alpha is equal to m omega over pi h cross power 1 over 4. So now you find the expectation value of x for both the cases. See, for both cases, this modulus square of psi naught x squared and modulus square of psi 1 x squared is even, and x is add integrand. So add integrand, here also x add. So add integrand within the limit, symmetrical limit, minus infinite to plus infinite, will become 0. So for both cases it will be 0. What about the expectation value of momentum? By definition, the expectation value of momentum is equal to the time derivative of expectation value of x is equal to 0, because expectation value of x is 0. So now we have this problem, as I said, consists of three parts. We will solve one by one. Now we have to find the expectation value of x squared. First we will find the expectation value of x squared for n equal to 0. That is psi naught, wave function is psi sub naught. Psi naught is equal to, as given in the problem, alpha e power minus z squared over 2. Then by definition, the expectation value of x squared is integral between minus infinite to plus infinite x squared modulus psi naught squared dx. So which can be written as, here the psi naught, modulus psi naught squared, you replace this. Then it will become psi squared, alpha squared x squared. If you square the exponential term, you will get e power minus z squared dx. Now you substitute this constant, that is alpha squared. Alpha as given is m omega over pi h cross power 1 by 4. So naturally alpha squared is m omega over pi h cross power 1 over 2. Then here you can see you have to replace this x squared, and you have to replace this dx, because we have to bring in terms of z squared. So we know, as given in the problem, z is equal to square root of m omega over h cross times x. Then what is x? Just you bring this to the other side. So this will become square root of h cross over m omega z. Then what is tx? Which is equal to square root of h cross over m omega dz. Now you replace this parameter here. So x squared, first I am replacing x squared. X is this one. Then x squared is h cross, just if you square this, you will get h cross over m omega, and z square. Z square I am bringing inside the integral. Then what is tx? Tx is square root of h cross over m omega dz. So I am replacing tx. So I am taking this constant out, which is h divided by m omega power half. This is then I have replaced tx by tz. Now what is the value of this integral? This is the Gaussian integral. So naturally, you know, the value of this Gaussian integral is square root of pi by 2. So now you can cancel some of the term. See, you can cancel this square root of pi with this square root of pi. So both will get cancelled. Then you can see this is m omega over h cross power half. This is h m omega power half. So this is just the terms inside the bracket is just the inverse of this. So this and this will get cancelled, become 1. This and this will become 1. So naturally the terms left out is h cross m omega. Here remember that you have 1 2. So this will become h cross 2 m omega. So the expectation value of x squared is equal to h cross over 2 m omega. Now we will see the expectation value of p squared for n equal to 0, that is for the wave function psi 0. As given in the problem, psi 0 is equal to alpha times e power minus z squared by 2. So by definition, the expectation value of p squared is integral between minus infinite to plus infinite psi star p squared psi dx. So now I am replacing p squared by its operator. P squared operator is by definition minus h cross squared t2 over tx2. So now you can see here you have x squared, here you have dx. All you have to change in terms of in terms of z. So you know x is equal to x is equal to square root of h cross minus m omega z. Then dx we have seen equal to square root of h cross over m omega dc. Now first you replace this dx. So by this one square root of h cross divided by m omega power half dz. I have replaced dx. Dx has been replaced. Then what about here? You have tx squared. So tx is equal to this one. Tx is equal to square root of h cross over m omega tc. Then tx2 is equal to, you just square it. You will get h cross divided by m omega tc. So you replace this tx squared by h cross divided by m omega dc squared. So in the denominator you have h cross m omega. So it will go to numerator. This will be m omega divided by h cross, and we have replaced the x by z squared. So you know that alpha squared is already we have seen so many times. Alpha squared is m omega over pi h cross power half. Now you can cancel some of the term. M omega power half will get cancelled to this m omega power half, and this h will get cancelled with this h. So now you will get minus h cross squared. Here 1 over square root of pi. Here first term you have 1 over square root of pi, and second term fully get cancelled with this one. So then third term m omega over h cross. So if you differentiate this twice, e power minus z squared over 2 twice, then you will get z squared minus 1 e power minus z squared by 2. So now you multiply this and this, because all are this number, you can no operator, so you can interchange. Then this will become z squared minus 1 e power minus z squared tc, and you cancel some of the constant. Here h cross square will get cancelled with this h cross. Then this will become minus 1 over square root pi m omega, this h cross will come here. 1 over square root of pi m h cross omega. Now you have to integrate this one. So first if you integrate this and this, using Gaussian integral, you will get square root of pi by 2. That is 1 over 2 square root of pi. Then if you take this and this and integrate it, this is also Gaussian integral, you will get minus, this is square root of pi. So if you subtract this from this, you will get minus square root of pi by 2. Here you can see this square root of pi will get cancelled with this square root of pi. So remaining thing is you have m h cross omega and this 2 divided by 2. This is the expectation value of p square. Now we will see the expectation value of psi 1, that is for n equal to 1, psi 1 is equal to alpha times square root of 2 z e power minus z squared by 2. We have seen now. The expectation value of x squared is by definition integral between minus infinite to plus infinite. X squared psi 1 modulus psi 1 squared dx. So modulus psi 1 squared I am replacing this. So which is equal to 2 alpha squared. Square root of 2 will become 2 when you square it, then alpha squared. Then if you take the square root of this, you will get z squared minus e power minus z squared, because if you square this you will get this denominator 2 go away, it will become e power minus z squared. Of course you have x squared like this. Now you change all the parameters in terms of z. First x we know is equal to square root of h cross over m omega c. So if you square this, you will get h cross over m omega c squared. Already there is another c squared, so this will become c power 4. Then you have to replace this dx. If you replace dx you know is equal to square root of h cross over m omega dc. So I have replaced dc and h cross m omega square root I am writing as power of. Then you know this alpha squared is equal to, if you square this, m omega over pi h cross power of. Already there is 2 here. Now what will happen if you integrate it? This is Gaussian integral. So if you integrate it, you will get 3 by 4 square root of pi. It's a standard gamma integration. Now we can cancel the sum of the things. This square root of pi will get cancelled with this square root of pi. Then you can see m omega h cross power of, here just the inverse of it, h cross divided by m omega power of. So both will get cancelled. So ultimately you will get h cross over 3 omega. Of course you have to take care of this 3 by 4. So this will become 3 h cross divided by 4. That is, you remember that already there is 2. That 2, this 4 will get cancelled. This will become 3 by 2. So in the numerator you have 3 h cross. In the denominator you have 2 m omega. So the expectation value of x squared for wave function 1 is equal to 3 times h cross divided by 2 m omega. Now we will find the expectation value of p squared for n equal to 1, that is wave function psi sub 1. So as given in the problem, psi is sub 1 is equal to alpha times square root of 2 z e power minus z squared by 2. So now by definition the expectation value of p squared is integral between minus infinite to plus infinite, as usual psi star p squared psi tx. Now I am replacing this p squared by its operator, that is minus h cross squared t2 over tx2. Then you substitute the wave function. You have that is alpha into alpha, you will get 2 alpha squared, because square root of 2 will become 2 alpha squared, then this exponential term. Of course we have z e power minus z squared over 2, here also z e power minus z squared by 2 tx. Now we have to replace all x by z. So we know x is equal to this, and tx is equal to square root of h cross divided by m omega tc. And if you take the square tx squared again, if you square it both sides, then you will get tx2 is equal to h cross over m omega t square, as we have seen already. Now you replace all these things here. You know this is the h cross squared minus h cross squared 2 alpha squared is m omega divided by pi h cross 1 over power 1 over 2, and I am replacing this tx. Tx is equal to square root of h divided by m omega, that is h cross divided by m omega power half. Then here tx squared I am replacing h cross m omega tc squared. So this h cross, when goes to numerator, this will become m omega over h cross, as we have seen earlier. Then now you have to integrate this term. So before that we can cancel some of the constant thing. Here you can cancel this m omega power half and this m omega power half, and you can cancel this h cross, this h cross. So here here you will have minus h cross squared 2, this is 1 over square root of pi, this is 1 over square root of pi. Then this m omega over h cross, we have to differentiate this twice. If you differentiate this twice, you will get z power 4 minus 3z squared, and this exponential term will come as it is. Now here you can cancel another term, this h cross squared will get cancelled with this h cross. So naturally this will be h cross. So I can write this minus 2 over square root of pi, this m h cross omega, then this integral. If you multiply this exponential term, you will get z squared, e power minus z squared. Now you take, this is Gaussian integral, this term and this term. So what will happen, z squared, if you integrate z squared e power minus, z power 4 e power minus z squared, then you will get integral value 3 by 4 square root of pi. Then what about next term, minus 3 times this z squared in this exponential term. If you integrate it, this is Gaussian integral, you will get 1 over 2 square root of pi. Of course this is multiplication, not 3.5. So if you subtract this, you will get minus 3 by 4 square root of pi, minus 3 by 4 square root of pi. If you subtract that is 3 by 4 square root of pi, 3 by 2 minus 3 by 2 square root of pi, you will get minus 3 by 4 square root of pi. So now this square root of pi uh, will get cancelled with this square root of pi will get cancelled with this square root of pi, and this 4 will get cancelled with this 2. So already there is one minus. Minus of minus will become plus. So I have taken this. Naturally 3 by 2. In the numerator you have 3 h cross omega multiplied by 3. Minus of minus, as I said, you will get plus. So in the numerator you have 3m h cross omega. In the denominator you have 2. So we have found that p squared is equal to 3m omega m h cross omega by 2. Then we will move on further. Now section P is checks the uncertainty principle for this state. That is, first for n equal to 0, that is psi 0. So for n equal to 0, psi sub 0, we have seen the expectation value of x is 0. So only the square root of expectation value of x squared. Expectation value of x squared is, we have seen, h cross divided by 2m omega. So we have to take naturally the square root. For sigma p, naturally we have seen that the expectation value of p is equal to 0. This is just the square root of the expectation value of p squared. Expectation value of p squared is m omega h cross over 2. That is, you have to take square root of that. Then you multiply sigma x and sigma p. Sigma x is h cross over 2m omega, of course with the square root. This is square root of m omega h cross divided by 2. Then here you can see this m omega, square root of m omega will get cancelled with the square root of m omega. Then in the numerator you have square root of h cross into square root of h cross, which is equal to h cross. Then in the denominator you have square root of 2, square root of 2, which is equal to 2. This is h cross divided by 2, exactly matching the uncertainty principle. Then the next case, n equal to 1, that is psi 1. In this case, we have seen expectation value of x here also is 0. Expectation value of p also 0. So sigma x is nothing but square root of expectation value of x squared. The square root of expectation value of x squared, the expectation value of x squared is 3h cross divided by m omega. Then here square root of expectation value of p squared. Expectation value of p squared is, we have seen, 3 times m omega h cross divided by 2. So now you multiply this 2, sigma x sigma p. This is square root of 3 h cross over 2 m omega, and this is square root of 3 m omega h cross over 2. Now you can see this here, this m omega and this m omega will get cancelled. So here you have 3 h cross, here another square root of 3 h cross into square root of 3 h cross is equal to 3 h cross. Similarly, in the denominator you have square root of 2 into square root of 2, which is equal to 2, which is greater than h cross by 2. This also satisfies the uncertainty principle. So section C is compute expectation value of kinetic energy T and expectation energy of potential energy V for this state. First, you take the case of n equal to 0, that is psi 0. So the expectation value is 1 over 2m expectation value of p squared. You know the expectation value of p squared is this one, m omega h cross divided by 2. Of course, you have 1 over 2m. Here, this m will get cancelled. This m will get cancelled with this m. So you will get h cross omega divided by 4. Similarly, what is the potential energy? Potential energy is equal to half m omega squared multiplied by the expectation value of x squared. So this expectation value of x squared is h cross divided by 2m omega. Here you can see this omega squared will get cancelled with this omega, and m will get cancelled with this m. So in the numerator you have h cross omega. In the denominator 2 into 2 is equal to 4. So if you add these two, you will get half h cross omega. So what is the nth state energy of harmonic oscillator? That is E0 here is equal to h cross omega n plus half. Here n is equal to 0. So naturally this is half h cross omega. This is exactly matching the original result. Now we will see the same for n equal to 1, that is psi 1. So the kinetic energy is 1 over 2m expectation value of p squared. Expectation value of p squared is equal to this one. 3m omega h cross over 2. Now this m will get cancelled. So you will get in the numerator 3 h cross omega divided by this 4. And similarly the expectation value of potential energy is of m omega squared, the expectation value of x squared. For psi 1 we have seen the expectation value of x squared is 3h cross divided by 2m omega. So now if you simplify the sum of the term, this m will get cancelled, and this omega will get cancelled to this omega squared. So in the numerator you will have 3 h cross omega, 3 h cross omega. In the denominator you have 4. If you add these two, you will get 3 by 2 h cross omega. So if you take h cross omega outside, this is n plus half. If n is equal to 1, what will happen? This will be 3 by 2 h cross omega, exactly matching with the original result. Thank you very much for watching my video and supporting me continuously. Thank you very much.